I welcome you all for the digital communication lecture module. In this lecture, we are going to discuss about a Hamming codes. So normally the Hamming code is a binary code which is used to detect and error and correct the single bit error. So it is a type of error detection and error correction code, and this code is applicable for a detection and correction of a single bit error. Okay, so for the detection and correction of error, normally the Hamming code use a parity bits. So the number of parity bits is added in the Hamming code, which is described with the given equation 2 power p, which is greater than or equal to p plus m plus 1. So here the m represents the number of message bits and the p represents the number of parity bits. For example, if the number of messages what we are trying to transmit is 4, then obviously the number of parity bits required is 2 power p, which is greater than or equal to, we don't have a p value, so p, instead of m we are going to substitute 4 because we have a 4 bits we are going to transmit plus 1. So if we add it together we are getting 5, so p plus 5. At the left hand side we have a 2 power p. So if you are substituting p equal to 1, obviously this equation will not satisfy. Similarly, if you are substituting 2 also, this equation will not satisfy. If we substitute 3, p equal to 3, 2 power 3 will give the value of 8. Similarly, 3 plus 5 will become 8. So this equation will satisfy here. So the minimum number of parity bits which is required to transmit 4 bits is 3. So we have a 3 parity bits and 4 message bits. So total number of bits has to be transmitted from the transmitter end is 3 plus 4, which is equal to 7. Number of message bits plus number of parity bits, which is equal to 7. So there are some common protocols or procedures are followed to add the parity bit along with the message bit. So these three parity bits will gets added with the four message bits. So there is some common procedure for adding the parity bit along with the message bits. So normally the parity bits are always added with the two power places, 2 power 0, it's a 2 power 0, 2 power 1, 2 power 2, like that. At this place 2 power 0 will become 1, 2 power 1 will become 2, 2 power 2 will become 4. So in this place alone we need to add the parity bits. So there is some common protocol. The parity bits will always get added at the 2 power places. So this is the introduction about the Hamming codes. So let's see the example of how the Hamming code is generated. So first we look at the problem. Generate the Hamming code for the message 1110. So this is the information message what we are going to transmit. So it has a 4 bits. Okay. So we need to generate a Hamming code at the transmitter end, and then we can able to transmit. So for this, the first step is we need to identify the number of parity bits required to transmit. So here we have a 4 message bits, as we discussed in the previous slide. If the m is 4, obviously the number of parity bits which is required is 3. So the number of bits which is required, parity bits is required is, if you are substituting, we are getting the value of 3. That's the first step. First step is we need to find the value of 3. And the second step is where we need to apply these three parity bits along with those four message bits. So first I am writing the bit position at the first row, 1, 2, 3, 4, 5, 6, 7, because we are going to transmit 7 bits, 3 parity bits and 4 message bits. So I am writing the 7 bit position. Secondly, so as per the 2 power order, we have a 3 parity bits. So it can be added at a 2 power 0 place. Look at here, 2 power 0 place, 2 power 1 place and a 2 power 2 place. 2 power 0 is 1. So at the first place, I am adding the parity bit 1. It is denoted as P1. And 2 power 1 is 2. So at 2, second position, I am adding the parity bit 2. At 2 power 2, 2 power 2 will give the 4. So at the fourth place, I am substituting the value P3. So with respect to the two power values, I am adding the P1, P2 and P3, three parity bits. So remaining we have a 4 message bits. Now those 4 message bits are denoted as M1, M2, M3 and M4. Okay. So we know the next step is we know the message bits. The message bits what we trying to transmit is 1110. So I am going to apply M1 as 1, M2 as 1, M3 as 1 and M4 as 0. So we are going to substitute the message bits and still the parity bits remains unchanged. We need to find these parity bits. We need to find the value of P1, P2 and P3. Then we need to substitute here. So for finding out the parity bits, we need to consider there are two types of parity is there. One is the odd parity and the second one is the even parity. First, let's consider the odd parity. So if P1 is odd parity, then out of 7 bit positions, we need to consider the following bit positions 1, 3, 5, 7. I will tell you why we have considered 1, 3, 5, 7 means here. Look at here, if we write this 7 bits, we need to transmit 7 bits, no? So if we write it equivalent binary, so we have a 00001. So until 7 we can able to write 111. So now out of this, look at it the column wise. The first column refers the parity bit P1, so the second column refers the parity bit P2, and the third column refers the parity bit P3. So now look at the column left side. From the right side, look at the column P1 here at the position 1, position 3, position 5 and position 7. So in these four positions, we have the value of 1. So that is position 1, position 3, position 5 and position 7. I have the values of 1, so that I am considering these positions for parity 1. So now look at here at the position 1 we have the value of p1, at position 3 we have the value of a 1, at position 5 we have the value of 1 and position 7 we have the value of a 0. So after substituting the message bits we have a p1 1 1 0. So already there are two ones are there. If the p1 is again, if I am substituting 1, then it will become a odd parity. So to make this as a even parity, this P1 must be a 0. So from this, to make this as a even parity bit, I am considering P1 as a 0. Similarly, now I need to find out the value of parity 2. So finding out the 2, look at the places in the center column. So we have the one at a 2, 3, 6 and 7. So for P2 I am considering 2, 3, 6, 7. At the now look at the table here. At the position 2 we have the value of P2. At the position 3 we have the value of 1. At position 6 again 1. Position 7 0. So we have a value of P2 1 1 0. Already there are two ones are there. If you want to make this as even parity, I need to make this P2 value as 0. So P2 is 0 for in the case of even parity. Similarly, if you want to find the value of P3, look at the last column here again, where the bits which is having one is at the fourth place, fifth place, sixth place and the seventh place. So I am considering 4 5 6 7. So at the fourth, fifth, sixth and seventh place we have the values of the p3 1 1 and 0. So similarly here also there are two ones are there. If you want to make this as even parity, obviously the p3 has to be 0. So by this case, if you want to make this as a even parity, all these value p1 p2 p3, all the values will become say 0. So these p1 p2 p3 values will gets added with this area. So finally if I add this, at the position 1, instead of this position 1 I need to substitute 0, in the position 2 I need to substitute 0. So p1 and p2 will become 0, and I already at the position 3 we have a 1, and position 4 p3 again it is 0. So 1 0 double 1 0. This is for the even parity. This is the Hamming code which we are going to transmit at the transmitter end. So in case of even parity, this will be in the reverse, vice versa. So if it is a even parity, odd parity, these values will become, see, instead of zeros, P1, P2 and P3 values will get 1 for the odd parity. So for the odd parity, those parity bits of 0 has been changed into the parity bits of 1. P1, P2 and P3 values changes 1. This called as, or this code is called for a Hamming code for the odd parity bit. So this is about a Hamming code. So Hamming code is a binary code. It is used for the error correction and detection, and it has been used for correcting errors in a single bit. So we, for the number of parity bits has been identified the given equation. So normally after finding out the number of parity bits, these bits has to gets added with the message bits and transmitted. So at the places or the positions which parity bits added is only the two power places. So and then we have look at the example. Okay, so we are taking four message bits, and then we have substituted, we need three parity bits, so we found the value of 3 in case of even parity, and then we have gets added with the message, and then for odd parity also we found the values, and that has been get added with the message bits. So this is how Hamming codes are generated and transmitted from the transmitter end. Thank you.